Welcome to Swift Interview Questions for iOS App Development. In this comprehensive series, you'll master the 5 essential concepts that every iOS developer needs to know for technical interviews. These include optionals for handling nil values safely, protocols for defining blueprints and contracts, closures for functional programming, memory management with automatic reference counting, and iOS architecture patterns for building scalable applications. Let's dive deep into each of these fundamental Swift concepts that will help you excel in your iOS development interviews. Optionals are Swift's way of representing values that might be absent or nil. Think of an optional as a container that either holds a value or is empty. The question mark syntax after a type name creates an optional type. For example, int question mark represents an optional integer that can either contain an integer value or be nil. Optional string can hold a string value or be nil. This safety feature prevents common runtime crashes that occur in other programming languages when trying to access null values. Swift forces you to explicitly handle the possibility of nil values, making your code much safer and more predictable. There are 2 main ways to unwrap optionals in Swift. Force unwrapping uses the exclamation mark operator to extract the value directly. While this works when the optional contains a value, it's dangerous because your app will crash with a runtime error if the optional is nil. This is why force unwrapping should be avoided in production code. The safe alternative is optional binding using if-let syntax. This approach safely checks if the optional contains a value, and if it does, the value is unwrapped and assigned to a new constant. If the optional is nil, the else block executes instead. This prevents crashes and handles nil cases gracefully. Swift provides 2 advanced optional binding techniques. Guard-let is perfect for early exit patterns and validation. It unwraps the optional and makes the unwrapped value available throughout the rest of the function scope. If the optional is nil, the else block must exit the current scope using return, throw, or continue. This keeps your main logic clean and unindented. If-let is better for conditional execution, where you want to perform different actions based on whether the optional has a value. The unwrapped value is only available within the if block. Choose guard-let for validation and preconditions, and if-let for conditional logic and branching scenarios. Optional chaining allows you to safely access properties, methods, and subscripts on optionals that might be nil. Instead of unwrapping each optional individually, you can chain them together using question mark operators. If any link in the chain is nil, the entire expression returns nil without causing a crash. For example, when accessing a person's residence number of rooms, if either the person or residence is nil, the expression safely returns nil rather than crashing. This is particularly useful when working with nested object hierarchies where any level might be optional. Optional chaining makes your code more concise and safer when dealing with complex optional relationships. The nil coalescing operator, represented by 2 question marks, provides a concise way to supply default values for optionals. This operator returns the unwrapped value if the optional contains a value, or returns the default value if the optional is nil. It's incredibly useful for user interface scenarios, like displaying a user's name or showing guest if no name is available. The nil coalescing operator works with any type and can be chained multiple times. It's much cleaner than using if-let statements when you simply need a fallback value. This operator is commonly used in user profiles, configuration settings, and any scenario where you need sensible defaults for missing data. Protocols in Swift define a blueprint of methods, properties, and other requirements that classes, structures, or enumerations can adopt. Think of a protocol as a contract that specifies what functionality a type must provide, without implementing that functionality itself. When a type adopts a protocol, it promises to implement all the required methods and properties defined in that protocol. Protocols enable powerful programming patterns like polymorphism and code reusability. They're fundamental to Swift's design philosophy and are used extensively throughout the iOS frameworks. Understanding protocols is essential for writing clean, maintainable Swift code and following best practices in iOS development. When a type conforms to a protocol, it must implement all required methods and properties specified by that protocol. Swift will generate compile time errors if you forget to implement any required protocol members. This ensures type safety and prevents runtime errors. Protocols can also inherit from other protocols, creating a hierarchy of requirements. When a type conforms to a protocol that inherits from another protocol, it must implement all requirements from both protocols. This inheritance mechanism allows you to build complex, layered contracts that types can fulfill. Protocol conformance is checked at compile time, making your code safer and more predictable than runtime-based systems. Closures are self-contained blocks of functionality that can be passed around and used in your code. They're similar to functions, but can be written inline and can capture values from their surrounding context. The basic closure syntax includes parameters in parentheses, a return type, the in keyword, and the closure body containing statements. Closures are incredibly powerful for functional programming patterns, event handling, and asynchronous operations. They're used extensively in iOS development for completion handlers, animations, and collection operations like map, filter, and reduce. Understanding closures is crucial for writing modern, expressive Swift code. Swift uses automatic reference counting, or ARC, to manage your app's memory usage. ARC automatically tracks how many references exist to each object in memory. When you create an object, ARC sets its reference count to 1. Every time another variable references that object, the count increases. When references are removed or go out of scope, the count decreases. When the reference count reaches 0, ARC automatically deallocates the object, freeing up memory. This happens without any intervention from you as a developer. ARC prevents memory leaks by ensuring unused objects are cleaned up, but you still need to understand strong references to avoid retain cycles. iOS architecture patterns provide structured approaches to organizing your code for maintainability, testability, and scalability. The three most popular patterns are MVC, MVVM, and Viper. MVC, or Model View Controller, separates data, user interface, and business logic into distinct layers. MVVM, or Model View Model, adds a view model layer to handle presentation logic and data binding. Viper, which stands for View Interactor Presenter Entity Router, provides even more granular separation of concerns for complex applications. Choosing the right architecture pattern is crucial for building robust iOS applications that can grow and evolve over time. Good architecture ensures separation of concerns, making your code easier to test, maintain, and extend.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.